Stargazers! Let's pretend you're preparing lunch. You're given the option between using bread or a tortilla in your meal. Which do you choose? Down here on Earth, that choice is a matter of personal preference. But on the International Space Station, that choice actually matters. In orbit, breadcrumbs don't just land on your plate, they float. Why? Because the space station isn't just hanging in space, it's falling. The station is traveling at over 17,000 miles per hour as it orbits the Earth. That means it's constantly falling around the planet. And everything inside it, astronauts, tools, drops of water, is falling too. This creates something called microgravity, a condition where objects seem weightless because they're all falling together. It's kind of like one of those rides at an amusement park that suddenly drops straight down. For a few seconds, your stomach flips, and you feel like you're floating because you're falling with the ride. Now, imagine that feeling lasting for months. That's what it's like on the International Space Station. This means even something tiny, like a breadcrumb, can drift away and cause trouble. It might get stuck in equipment or end up in someone's eye. Ouch! That's why astronauts go for tortillas. Less mess, fewer floating hazards, way more space-friendly. These types of challenges are just part of life on the International Space Station, where ordinary routines meet extraordinary conditions. The International Space Station is a science lab, a home, and a place to test ideas for future space missions, all orbiting about 250 miles above Earth. It's been continuously inhabited for over 2 decades by astronauts from around the world. It's one of the most ambitious engineering projects ever built, and it exists to help us better understand space, science, and ourselves. Today, we're exploring what it's like to live and work in space, how microgravity makes the space station a one-of-a-kind research facility, and how this giant spacecraft is a shining example of how international teamwork drives scientific discovery. Life on the ISS is definitely not your average job. From floating through modules to brushing your teeth without running water, daily life in orbit is full of weird, wonderful routines. Let's start with movement. Astronauts don't walk. They glide from place to place, gently pushing off walls and railings. It looks super fun, until you realize there's no such thing as plopping down on the couch. Everything has to be strapped, zipped, or velcroed to keep it from floating away, including you when you sleep. Floating around all day might look easy, but an astronaut's body pays the price if they're not careful. Without regular exercise, their muscles shrink and bones get weaker. To stay strong, astronauts hit the space gym, running on a treadmill with a harness, cycling in place, and lifting weights. Imagine you're designing a workout for astronauts. Which of these do you think would work better in space? Free weights or a resistance machine? Why? Pause the video and make a prediction. On Earth, your muscles fight gravity to lift the weights. This creates a lot of work for your muscles. But on the ISS, free weights float, just like breadcrumbs and astronauts. They don't require much effort to move, so they don't give your muscles a real challenge. That's why astronauts use resistance machines. These use springs or cables to create force, so muscles still get a workout. But keeping in top physical shape isn't the only priority for astronauts. Mental health is just as important, especially when you're living in a small space far from home for months at a time. Astronauts stick to regular schedules, talk with family over video calls, and even have movie nights or celebrate holidays together. It's all about staying connected and keeping spirits high. Of course, living in space isn't without risks. Radiation from the sun and deep space can be dangerous. So, the ISS has shielding built in areas that are regularly checked to make sure radiation levels stay safe. If radiation levels spike, astronauts can move to more protected areas inside the station. Then there's space debris. Tiny pieces of junk from old satellites and rockets are zipping around Earth at crazy speeds. If a piece comes too close, the crew gets an alert, and in rare cases, they might shelter in their return capsule, ready to evacuate if needed. But don't worry, that's rare, and the station can adjust its orbit to dodge most of it. Despite the challenges, astronauts adapt with creativity, teamwork, and a lot of preparation. Living in space may not be easy, but it's a unique experience that's worth every floating tortilla and treadmill run. And adapting to life in orbit is just the beginning. The real story is what astronauts are working on while they're there. The International Space Station isn't just a place to live, it's also a floating science lab. And thanks to microgravity, experiments can be completed that simply can't be done on Earth. Earlier, we talked about how microgravity makes everything float because the station and everything inside it is falling together around the Earth. So, why does that matter for science? Because in microgravity, the effects of gravity are reduced. That gives scientists the chance to observe how things behave when they're not being pulled down the way they are on Earth. Liquids form into perfect floating spheres. Flames flicker in strange round shapes. Even living cells grow and behave differently. Without gravity dominating everything, scientists can study processes in new ways, and sometimes they discover things that aren't even possible to see on Earth. Scientists take advantage of this to study everything, from how human bodies change in space to how materials melt and mix. Astronauts have grown 3D tissue samples, studied how bacteria behave, and even experimented with protein crystals to help design better medicines back on Earth. And sometimes, astronauts step outside the lab. Literally. Spacewalks, which are officially called EVAs, or extravehicular activities, are done to make repairs, install new equipment, or run certain experiments that need to be conducted outside the station. It's risky work, but it's also one of the coolest parts of the job. Microgravity research has helped scientists design better medicines, water purification systems, and new medical tools. It's also helping us learn how to grow food in space, knowledge that's essential for future missions to the Moon or Mars. All of that incredible science happening on the International Space Station? It's not the work of just one country. This spacecraft isn't just international in name, it's teamwork on a global scale. Building it took the cooperation of 5 major space agencies: NASA from the United States, and the space agencies of Russia, Europe, Japan, and Canada. And over a dozen countries and smaller space agencies contributed parts of the space station, like labs, living quarters, and solar panels. These parts were built on Earth, launched into space by rockets, and then carefully connected together while orbiting the planet. Crew members come from all over the world. At any given time, there might be astronauts from the US, Russia, Germany, Japan, Italy, or a different nation, all living and working side by side. That means astronauts often speak multiple languages. English and Russian are the main languages used on board, and many crew members learn both during training. Communication is key, whether you're running an experiment, checking a system, or suiting up for a spacewalk. During the space race, countries competed to outdo each other, but the ISS tells a different story. Countries with different languages, cultures, and histories came together to build and run the ISS, sharing data, solving problems, and keeping things running. And as we aim for the Moon, Mars, and beyond, that spirit of unity will be just as important. It proves that space exploration isn't just about rockets. It's about what we can achieve when we work together. So, next time you look up at the night sky, remember, there's a football field-sized space station up there filled with people doing science, solving problems, and proving what's possible when the world works together.
Hey!